Okay, in this video we're going to talk about linear regression. And you may recall from your stat class that regression finds the relationship that exists between two variables. In this case, one of the variables is time or week, and we're going to put that on the x-axis, and then we're going to put demand on the y-axis. So here's time. In our example, it's week 1 through week 52. And then over here we have demand. And what we can do is we can plot the particular demand that was experienced during a particular week. And then what linear regression will do is it'll find the line that best fits that data. Is that ringing a bell? So what that line actually does, that we're going to let regression define for us, that line finds that regression finds the particular line that minimizes the sum of squared errors. Well, the error is the distance from the line to these data points. Okay, so the line that regression spits out minimizes the sum of all of these little errors squared. So if we were to square those errors and add them up, we get the sum of squared errors, and the line that regression spits out gives us the line that minimizes that sum of squared errors, or that sum of squared distances, if you're a visual person. So that's what's going on. Well, the first thing we want to do before we use linear regression is see if a line actually is appropriate to describe the relationship that exists. So we have a relationship here between time and demand, and we want to check and see, does that relationship actually look linear, or is it curvilinear? So what I'm going to do is I'm just going to insert a little chart, scatter plot, and we're going to look at that data across time. Okay, so I had highlighted the data, including the column headings, prior to hitting insert scatter plot. And now I can look at that data over time. So, for example, in week 10, go straight up, it tells us that's where demand was, and so on and so forth. And there does, in fact, tend to be, or appear to be, something somewhat linear going on here. A positive trend. Over time, demand is going up. So it might be that a linear trend is appropriate. In fact, it is for this data that we see so far. So what I'm going to do now is I'll get rid of that. And now I will determine the slope and the y-intercept of that line. Okay? And there's a number of ways you can do that in your book. I think they go through the actual calculations, which no one's going to ever do in the real world. But you can use Excel to run a regression directly. But we also have some basic functions. We have the slope function. So we plug in the y's, which in our example or correspond to the demand column. So we would type in B2 colon B53, and the known x's would be A2 colon A53. Enter. And that's going to spit out the slope. Okay, so almost a perfect slope there. Coincidentally, the other thing we can do, the other thing we need is the y-intercept, and for that Excel has a formula, intercept, as you might guess, and it's the same thing. The known y's, which are B2 colon B53, and the known x's, which are A2 colon A53. Okay, and now we have the intercept and we have the slope. And what that's telling us is right here is the y-intercept. It's saying that the line intersects the y-axis at about 40. And then every time we go over 1 week, we go up a little more than 1, where we call that slope as rise over run. So as we go over 1, we go up a little more than 1. Not much more than 1, but just a little bit more than 1. And that defines our line. So you realize quickly you can define any line. If you know where it hits the axis, and you know the slope, then you've got the line. Now what do you do with this? Well, we would use this line to calculate um, future sales. So for example, if I wanted to know what our sales going to be next week and I wanted to use the linear equation, I would say that sales will equal the y-intercept, which is in cell D8, plus that slope, D6 times 53. So again, we started at the y-intercept and we've gone up the slope 53 times. And where does that put us? Puts us at 94.45. So we could use the linear trend equation to basically see where that trend is headed. So in our example, what we just did is we had time here, we had demand over here, we had our data points, and they were going up. We defined a line, and we were at week 52, and we're wondering, what about week 53? What's going on right there? And our line gave us that point right there. So that point right there would be the 94.45 in this example. And that's how you might use a linear trend equation to forecast future sales. It tells us what the slope is, and that slope is analogous to growth we're experiencing, or it could be decline. In our example, it's growth. Okay, that's linear regression.